Hello, everyone. Welcome back to my CellRank video tutorial. In my previous video, we realized the gene expression trend. So in today's video tutorial, we are going to connect the gene expression trends. So you can follow previous video to know all the data and perform required analysis. Then we can continue to today's analysis. Okay, you can see in previous video, the last step we used the heat map to realize the gene expression trends. So today we can continue our analysis to connect the gene expression trends. So first we can use the function connect trends. The data will be A data, model will be the GM model. We are going to use the beta cell lineage for demonstration again. So we need to set the lineage argument as beta. Then data K will be magic imputed data. Then for the genes, I'm going to use all the genes in this data set. If you look at the online tutorial, they use the highly variable genes that can speed up the analysis in this step. So the time key will be plant pseudo time. So let's run this function to compute gene clustering. Okay, you can see it is running because I used all the genes. So here we are going to cluster the total genes 5,974 genes. Okay, we finished the clustering for all the genes. You can see it took just over 2 minutes to finish the analysis. Now you can see our gene clusters down here by their expression trends. You can see in total we have 9 gene clusters. So you can see gene in cluster 0, they have higher expression in the middle. Later we will show genes with the cell clusters. The NGN3 high expression cell clusters is located in the middle, this area. Then you can see genes in cluster 1 are downregulated. Then genes in cluster 2 were upregulated. So in cluster 3, you can see it has a high expression in the beginning, then downregulated, then upregulated again. Similarly, cluster 4 had high expression, downregulation, then even higher upregulation. Cluster 5 is similar to cluster 1, it is downregulated. Then cluster 6 gradually upregulated. If you see the value here, it's 10. So gene in cluster 6 are highly upregulated at the end of the cell stage of differentiation. Then cluster 7 and 8 upregulated in certain stage, then downregulated in the differentiated cells. So you can see we have 9 gene clusters here. They show different expression trends, but all the genes in the same cluster has similar gene expression trends. So if you say up here, we save the analysis in the A data named the lineage beta trends, so we can access this data and get it as G data. Then we can have a look at the G data. You can see now we have 5,971 observations and 200 variables. So now it is different from the A data because here the observations are the cluster number for each gene. So you can see we analyzed all the genes, but 3 genes were not clustered into any clusters. So the variable name will be the X test. So we can have a look at the G data observations. Let's run. You can see the observations now, it's the cluster number for each gene. So we got the gene cluster number. Now we can analyze the gene clusters. First, let's have a look at the G data again. You can see here we have the PCA information. We also have the neighborhood information. You know, normally when we cluster the cells, after PCA and the neighborhood, we can run the UMAP. So now we can run the UMAP for the gene clusters. Let's run UMAP, then have a look at the G data again. We can run. Okay, you can see now we added the UMAP information in the observation multiple layers. So now we can plot the embedding, use the UMAP information to see the gene clusters. We can count the gene by their cluster number. Let's create the UMAP for the gene clusters. So you can see we have 9 gene clusters here. I showed you already in the beginning. We have 9 gene clusters. They show similar gene expression trends in the same gene cluster. So first, let's have a look at some marker genes to see where they are. For example, we can use the FEV gene. It enables the cell clusters after the NGN3 positive cell cluster. And also we can have a look at the insulin 2. It enables beta cells. ECG glucagon enables alpha cells. SST, somatostatin enables delta cells. Then PPY enables the PP cells in the pancreas. So next, we want to make sure the genes that we selected here are in the dataset. So first we generate array data for all the genes. Then we can subset the genes that we listed here to make sure we have all 5 genes in the dataset. Then we can retrieve the index for each gene in the UMAP cell clusters. At the end, we can use the scatter plot to see where are the 5 marker genes. So now we can run this code. Okay, you can see the first figure is still the cell clusters. Then we can see if EV gene expression, it is in cluster 8. Then the rest genes, insulin 2, glucagon, somatostatin, and PPY, all of them are in the cluster 6. We can confirm the cluster number for biomarker genes using the observations. We can run. You can see if EV gene is in cluster 8, the rest of genes are in cluster 6, which means all the genes in cluster 6 are genes expressed in the terminal state cells. So genes in cluster 6 will be the genes that are expressed in terminal stage cells. So we can make a more plot to show the highly expressed genes in each gene cell cluster. So first we can get the gene expression level from the A data to the G data. This information is in the A data variables. We can have a look at the A data variable. Let's run. You can see we have the means for each gene expression in this data set. So we can get the mean expression from the A data and add it into the G data. To do so, we will merge the means observation from the A data into the G data observations. After that, we can have a look at the G data observations. We can merge it. Now you can see in the G data observations, we have the cluster numbers for each gene. We also have the mean expression for each gene in this data set. Then we can make a UMAP plot again to see the gene expression level for each gene in the gene clusters. We can run. You can see the first figure we generated is on the left to show the gene clusters. Then on the right-hand side, we show the mean expression for each gene in this dataset, because in this UMAP plot, each dot represents a gene. So in total, we should have 5,971 genes here. So we have the gene cluster number. We also have the mean expression for each gene in the data. So now we can rearrange the gene in each gene cluster by their expression level from the highest to the lowest. Then we can select the first 9 highly expressed gene in each gene cluster and visualize their expression trends in the cell clusters. Basically, the gene clusters were named by the number according to the total genes in each gene cluster. So number 0 has the highest gene number, then number 8 has the lowest gene number. But if you see from here, we can demonstrate later by the gene expression trends. So the initial stage genes are in cluster 0 and they are organized by their pseudoterm. Then cluster 6 are the genes expressed in terminal stage cells. So first we can see the highly expressed genes in cluster 0. If we run, we will make a line plot according to the term K plant pseudoterm. You can see the highly expressed genes in cluster 0 are highly expressed in the NGN3 high expression progenitors. Then we can have a look at cluster 1. We will do the same to sort the genes. Then we can plot the gene trend for 9 genes selected from here. We can run this code to see the gene expression trends in gene cluster 1. Let's run. So you can see we generated 9 figures for the top 9 highly expressed gene in gene cluster 1. You can see from here, all the genes in cluster 1 are downregulated, and we see the trends for all the genes in cluster 1 already in the beginning. Then cluster 5 will be the same. Genes in cluster 5 are also downregulated in later stage of cells. Let's run cluster 5. You can see, similar to cluster 1, genes in cluster 5 were downregulated. Then we can run cluster 2 for the top 9 genes. You can see genes in cluster 2 are upregulated in the FEV positive cells. So basically cluster 2, cluster 7, and cluster 8 show the same expression trends. They have a high expression in the FEV positive cell clusters. We can run cluster 7. You can see gene in cluster 7 also show high expression in the FEV positive cells. And we have one more cluster 8. It shows the same expression trend with the high expression in FEV positive cells. If we run for the cluster 8, we actually can identify FEV gene as the top line gene. You can see the first one is FEV. it is highly expressed in the FUV positive cells. So now we have canasta 3, 4, and 6 left. We can run top 9 genes for canasta 3. You can see genes in canasta 3 start to upregulate in the terminal stage cells. It will be the same for canasta 4. If we run for canasta 4, you can see genes in canasta 4 also show upregulation in the beta cells. So the last canasta is the canasta 6. I already showed you all the genes that we can label terminal stage cells are in the canasta 6. So let's run the top 9 gene for canasta 6. So we generated the 9 figures. You can see PPY, GCG glucagon. We have insulin 1 here. We also have insulin 2 here. So they are marked genes for the terminal stage, beta cells, alpha cells, and PP cells. So genes in canasta 6 are the terminal stage genes. So we run the expression trends plot for top line genes in each cell canister. Now we can go back to look at the 9 cell canisters again. You can see here are the cell canisters. Basically, through the gene expression trends from the line plot for each cell canister, we know canister 0 are the genes highly expressed in the NGN3 positive cells. Then canister 2, 7, and 8 are the genes highly expressed in the FEV positive cells. Then canasta 1 and canasta 5 are the genes that are downregulated in the progenitors. Then genes in canasta 3 and canasta 4 are in the pre-stage. Genes in canasta 6 are the genes that express in terminal stage cells. Okay, so that's today's video tutorial. I hope you can see this analysis is very useful to identify gene canisters in different cell states. If you want, you can also save the gene canisters into a CSV file. Then you can see all the genes that are highly expressed in each cell canister. You can use those genes to perform signaling pathway analysis and identify their gene functions. So I'm going to stop from here. If you like my video, please share it with your friends. Thank you.